Hello, my name is Noel D'Souza, and this is my video report for my Physics 2211 lab. So this is the code, some of the code for part 1. So I set the mass of the star to 2 times 10 to the 30 based on the requirements, and I set the delta T to 86,400. And then I updated the V initial, V final, P initial, P final, and delta V and delta P. Okay, so dp dt is just obviously delta P divided by delta T, and then Fnet is dp dt. So then I calculated P hat, and then a whole bunch of other things, and then at the end I'm updating the star position. Okay, so then I updated like the arrow stuff, so I set the scale to 9 times 10 to the negative 18, and then the positions to the correct values. Okay, so this is the output and the final result, and you can see that it printed out a bunch of different possible values for the black hole mass, and then it took the average of those values, and that came out to be around 8 times 10 to the 33, which makes sense because black holes have a lot of mass. That is a really big number. Okay, and then the answer to question 1, so the net force is equal to the rate of change of the momentum, and then the parallel force, so the net parallel force changes the speed, and then the net perpendicular force changes the direction. Okay, and then here are the values that I found that work best for the part 2 code. So I set the x speed of the ship to negative 380 and the y speed to 1180. Okay, so then this is the other part of the code that I edited. So this basically just finds the forces of the things on the other things. So it finds the force of the planet on the moon, the ship on the moon, and then the net force is the combination of those two. And then it finds the force of the planet on the ship, the moon on the ship, and then the net force again is just the combination of those two other forces. Okay, and as you can see, the ship did not collide with the moon, so it's all good. It ran for 700 hours, and it was able to go the whole time without colliding into anything, so that's always good. And for the answer to question 2, so to predict the motion of the entire system, the model would need to take into account all of the gravitational forces, so like the black hole, the stars, planet shape, or spaceship, and the moon. And then the dominant forces would come from like the heaviest things, so the stars and the black hole would definitely like dominate and outshine the other gravitational forces just because they have so much more mass than everything else does. Thank you so much for watching. This has been my presentation for Lab 3.